Computer, here we go. All right, so as I was just mentioning to those that are here tonight, I'm going to fly through decimals kind of fast tonight and talk about a few things related to it, but you can watch the short video in Canvas if you want more, okay, if you'd like a little bit more here. But so what I have is on the screen is just too much for you to all copy down now. So if you want to watch the video, you can. If you want to just take a picture of this with your phone real quick, you can do that as well. But I'm using introduction to decimals. That's what I want to do first, is just talk about what a decimal is. And you know, I think the easiest way to think of decimals is to think about this. If I did this on something, it went $25. Okay. You know, oh, there's the dollar symbol, and that's $25. Okay. If I went like this, you would go, oh, that's easy. That's $25.10. Okay. So everything in money, when we're talking about money, after that decimal point is cents, you know, whether it's 0.35, 35 cents, or if it was 0.129, it gets a little hard to figure that out of cents because the two's in the hundredth place, but we're familiar with money and decimals, right? So this little thing right here, okay, that I'll put make it nice and big here in the middle of the screen here. That's the decimal point. And previously, in previous years, we taught students that everything to the left of the decimal point goes ones, tens, hundreds, thousands, 10,000s, 100,000s, millions, 10 millions, 100 millions, billions, etc. Okay, but it starts with the ones place and then goes to the tens. And you'll notice it's just NS, okay, or DS, how it's spelled, okay? Everything to the right of the decimal point, okay, now I'm talking about going this direction here, is it starts with the tenths place, okay? So what I'm going to do is circle the TH right here, because I want you to notice there's two differences. There's no one-th place, okay, just so you know, there is no one-th place in the, when we're talking about decimals, there's no one-th place. There's a 10th place, then 100th, then 1,000th, then 10,000th, and it goes the same as it is over here on the left after you start with a 10th place. But notice, if you will, there's a TH every time. And the reason I'm kind of pointing this out to you, that's an H right there, by the way, is that whenever you see words, numbers spelled out with THs like this, 100th, 10th, 1,000th, with that TH in it, that means it's a decimal. It's a decimal place, okay? It's to the right of the decimal mark. And so that's what decimals look like. So the two difference between what we call whole numbers, which are over here, these are called whole numbers, and decimals, two differences are: one, there's a ones place with whole numbers. There is not with decimals. It starts with 10th. And the second thing to clue in is this TH here that I've put boxes around. That's a clue to you that we're talking decimals, okay? And then also just to remind you that it's kind of like money, $25.10. All right, moving on from there. What I'm going to do is that when you're adding decimals, so if you're taking notes, just write these two words right here, adding decimals, okay? And then you might want to write underneath this, the rule is to line up the decimals. In fact, you might want to say when you're adding and subtracting decimals. So it's both, if I put this over here, adding and subtracting, okay? That's the rule. Is if we can cover those all at once here, that'll help tonight, both adding and subtracting. So if I have an example here, add 13.23 plus 1.2, okay? The way you add decimals is you would write it like this, 13.23, and I'm going to line up my decimal points. One, see this one right here? I'm just put an arrow here. This is 1.2. Okay. And then this is the way I want you to do it on paper. Put a little plus sign here. And then before you do anything, put this decimal right here. Okay. Because by doing that, you are going to make sure your decimal's in the correct spot. Now I can just do the adding, 3, 4, 3 plus 1 is 4, and 1. Okay, so I just added these up here, and my decimal's in the right spot. So notice, again, I want to reinforce this. When you're adding and subtracting decimals, all you have to do is line up the decimals and then add. Okay, so I'm going to go through the next example kind of fast here. If they ask you to add 1.1 plus 27.56 plus 1.97, probably what I would do, just because I like it visually like this, it doesn't change the answer, but I like it like this. I'd put the biggest number on top. I'd go like this, 27.56 if I was doing this by hand. And I'd look at the next one, 1.97. And then I look over here at this 1.1 and go 1.1. And then, just like I taught you, I'd put the decimal right here. And then I would just add. Okay, so what you see there is that I lined up my decimals all the way down, including in my answer, and then I would add normally. Okay, so that's the rule for adding and subtracting decimals, is that you just need to line up your decimal. Let's go through a couple of quick examples. If I had this one here, I do want to talk about this one. I specifically put this example here because of this number 5 here. If you had $5, okay, if I had $5 here, it would be written like something like this, 5.00. Okay, do you see how you can look at that and hopefully recognize that's what $5 looks like, right? Do you see how the decimal point is right there? Okay, it's assumed, let's say that word again, it's assumed that in every whole number, like 5, that the decimal point goes right after it. So for instance, if I said I have $100, okay, it's assumed that the decimal point would be right here, okay, $100 here. That's $100. But we don't write it there because we don't really need it. We know it's $5. Or unless there's money or change or something like this. But normally we don't write that last little decimal unless it was $100.50. Okay, then we would put the decimal there. Okay. Now, the point I'm making is that what do you do when you're adding? You're supposed to line up your decimals, right? And I'm adding this 5 and it doesn't have a decimal. Okay. Here's how you would handle that. You would write 5 point, and you can do it just like that. Okay. And I'll just take my next number, 3.72. I just took, that's this one here. And then the next one is 0.781. Okay. And once again, I'm going to put my decimal where it belongs. And then I'm just going to add. Okay. So if you get a whole number, this could have been a 25 or a 35 or 305. Assume the decimal goes right after the whole number. Okay. And you just place it in there and just add. Okay. All right. Let's keep going here. Now, another concept that you'll be asked to do in your homework is they'll ask you to round things. Okay. And so you want to pay very careful attention to what they're asking you to round and when. All right. So, like for instance, in the equation that we have on the screen here, okay, if they ask you, listen to this very carefully, if they ask you to round these two numbers here that we're adding here, that I'm drawing my dots circling, round them to the nearest tenth and then add. You see how I said that? Round them first to the nearest tenth, then add. Then here's what I would do. This place right here, this 6 right here is in the 10th place. Because remember, I told you there is no 1th, it goes 10th, 100,000. I would underline the 10th place, look at the next digit to the right, and if it's 5 or more, this 6 goes up 1. Okay, so this would equal, if I rounded it to tenths, if they asked me to round first and then add the two numbers, this would become 3.7, and that's it. Everything else is just like 0. Okay, and this rounded up because this 7 right here to the right is 5 or more. This next number, 1.4, you'll notice the number to the 4 is in the 10th place. Okay, I'm talking about this 10th place right here. It's asking you to do this. Okay, 4 is in the 10th. The number to the right is not 5 or more, so 4 stays the same. So what I would write this as 1.4, and then I would add. okay? And I'll go ahead and put the decimal there, 7, 8, 9, 10, 11, carry the 1, 3, 4, 5. So my answer would be 5.1, okay? So that's what you would do if they ask you to round the numbers to the 10th first and then add. All right. Now, sometimes it'll ask you, and again, I'll say, repeat this, read the question carefully. It'll ask you, add the two numbers up and then round your answer to the nearest 10th. So in that case, if I had this, we'll call this problem number 2 down here. This is problem number 1. First thing I would do is line up my bit decimals. I would go 2.603, and then I would go 1.09, and I would put my decimal in my answer. Notice I've got them all lined up here, okay? Then I'm going to add real fast here, 3, 9, 6, and 3. All right. In this case, I now have an answer, 3.693. But if they ask you to round your answer to the 10th, I'm going to look in the answer here. And what I'm going to do is I'm going to go, okay, 6 is in the 10th place. I have a 9. So my answer would equal 3.7. Okay. So that's rounding to the nearest 10th place. Okay. So a little bit about rounding. Hopefully you've kind of had that before a little bit. If they ask you to round these numbers here, I'll call this problem number 1, to the nearest 100th place, here's how I would do it. I would start here just to the right of the decimal, and I would go tenths, hundredths. This 3 is in the 100th place. I underline it. I look to the right, that's 5 or more. So this becomes 0.44. Okay, that's what this would become. I look at my next number, it says to round to the 100th place. Be very careful and deliberate about this. Go 10th, 100th. Make sure you underline the right number because it changes everything if you don't. And I look to the right, it's not 5 or more. This becomes 0.34, okay? Because the 4 stays the same because of this 4 here is the same. Then I'm going to put my decimal in my answer, and then I'm just going to add real quick, okay? So again, this is how I would round to the 100th place if they asked me, pause, to round first to the 100th and then add. If they just said add the numbers and then round your answer to the 100th place, I would do it like I did in the previous slide. Okay, I'm going to move on. Sometimes they'll have an equation where they'll ask you to do two different things. They'll say, hey, the first one here, round it to the 10th place, but the next one, round it to the 1000th place, okay? So here's what that would look like real fast. I would go, okay, here's the 10th place, 10th, 100th, 1000th, okay? Number to the right's not 5, so this becomes 0.5, and it stays right there. That's all it is. Thousands place, I go 10th, 100th, 1000th. I underline the 1000th place. The number to the right is not 5. So this becomes 0.434. Okay, 0.434. And then I'm going to go ahead and put my decimal down here first, and then I'll just do my math real fast. Okay. So that's a little bit about rounding, a little review of rounding there. Okay. Now, subtracting decimals, I've already told you, so I'm not going to spend a lot of time here on this slide. Don't worry about trying to copy it all, but it's the same rule. Line up your decimals and then subtract, okay? So in this case here, I have 1.7, 0.9. Do you see how I have my decimal lined up? So I'm going to put it right there in line. I would have to subtract and borrow. So I'd cross out the 1, make it a 0, bring over the 1. 9 plus that is 8. Okay, I'm subtracting here now, 17 minus 9. This becomes 0.8. Okay, all right, so that's how I would subtract. Hopefully you remember subtraction. But what do you do over here when you got this number 3 over here? Okay, it's a little bit, we got to borrow. So I want to show you, you might consider, if you forget like how to subtract, you might copy this problem down and how I do it real quick. Okay, the first step, I got 5 minus 0.781. I'm going to put a decimal where it would be after the whole number. I'm going to put a decimal in the answer. And then here's what I would do, okay? I would fill in zeros here. I'm going to put my zeros here. And if you remember, when you subtract, you can't subtract a bigger number from a larger number. Okay. So you got to go all the way over here to borrow and make this a 4. Bring the 1 over. So that's now 10. I'm going to use different colors so it shows up differently. Okay. Cancel out the 10, make it a 9. Bring the 1 over. Cancel out the 10, make it a 9. Bring the 1 over. I now have 10 minus 1 is 9. 8 from 9 is 1. 7 from 9 is 2. And 0 from 4 is 4. My answer is 4.219. Okay. So I wanted to illustrate how do you handle it if you've got, there's no numbers over here, fill them in with zeros, and then you're going to have to borrow. Okay. All right. So that's subtracting and borrowing. And then I'm not going to review this because we just got through talking about if they round by 10th, we've already talked about the concept it's related to. And money, same thing. You're just familiar with that. So if you see a story problem. All right, let's look at least a couple of story problems. And Elizabeth starts with $28.53 and spends, okay, she's spending, so that's like minus $3.78 on pencils. How much money does Elizabeth have left? All right, this happens to be a nice example, as I taught you last week, in the story problems, where we look for the question with a question mark. And then once we find that sentence, we look for the keywords. And left usually means, I say usually because I'll have an example in a moment where it doesn't, but usually left means subtract. So what I would do is, okay, I see the keyword there, left means subtract. I see the question mark. I take my biggest number and put it on top. Remember, I told you when you're having to do a story problem, always put your bigger number on top. 3.78 is my other number. That's how much she spent on pencils. I put the decimal in the answer, and then I would just subtract. Okay. Look at number 3 here. Susan has $167.51 and Marty has $88.49. How much money do they have together? Okay. Again, here's the question with the question mark. Yeah, that's the sentence. Here's the word together is my key word, which means plus. So I'm just gonna line those up. 167.51 and add it to 88.49 and add. Okay. That's how I would do that, because I've looked at this word together means to add. All right, moving on. After buying some tickets for $82.14, John has $47.25 left. How much money did John have to begin with? Okay, this is the trick one I wanted to show you. It does have the word left here, right? And usually I said that means subtract, but I want you to notice something. Notice how the key word here is not in the question sentence. Here's the question sentence right here, okay? And this is the sentence with the question. And so it says, how much money did he have to begin with? Okay, well, if he started with this amount, but he has this much left, okay, he's going to buy some tickets for this much, and he has this much left. If we add those two together, that'll give us the answer. So I'm just going to write the word add them. The phrase add them, okay, just so you guys can see that that's what you're supposed to do if you look at my notes that I'll send to you tonight, these notes, okay. All right, and the next one's a classic example of the word left. Billy starts with $53.71 and spends $36.50 on tickets. He starts with this, but he spends money, okay. Missy spends $6 of Billy's money. So Billy's got the money. Missy's spending $6 of his money. How much money does Billy have left? Again, I want you to notice this is the sentence with a question mark. Here's our key word in the question. Yeah, we're going to do something with that, okay? So what we're going to do is we're going to take the $53, okay, he starts in 71 cents, minus he spent money, spends on this right here, and spent on this. So what I would do is I would add 36 and 36, and that would give me $42.50. And so I would do something like this, 0.50, and go minus. So I did that kind of fast, but what I did was we got two things being spent on, okay? We spend money on tickets, Billy does, and then Missy spends $6 more of Billy's money. So I added this 6 plus this 36 to get a total of 42.50. And then I subtract that to find out how much is left. Okay. All right. You know what I'm going to do for the sake of time is I'm going to jump over to the next concept because I wanted to spend, well, 35 minutes or more. We'll spend some time on this new concept. So here's where I'm going to actually slow down a little bit and let you take some notes. Okay. So we'll start with the first slide here. One-step equations. We're talking about algebra. So if you are taking notes tonight, or whenever you're watching this, in your notes, put down one step, maybe even the word algebra equation, okay? Because, okay, that's algebra. Algebra equations, one step, all right? And then the first thing I want to tell you is, it's kind of, we could call this the addition principle, okay? And you know, if you want to call it, but first of all, let me just talk about the goal of algebra. The goal is to get the goal of algebra. Okay. And by the way, if you were right now getting really nervous because I'm talking about algebra and you're going, I hated algebra. That's with X and A and B and C, I got lost. And hopefully this will make some sense for you. Okay. I also made a video that's sitting there in Canvas week 7. You can watch if you want to watch it a little slower or a couple of times, but the goal is to get X by itself. And once you get X by itself, you'll know what X equals. Okay. Now I want you to look at example number 1 here. Okay. It says 5 plus X equals 9. Now, hopefully at this point in your math expertise, you can go, well, what 5 plus 4 is 9. The X has to be 4, right? You could do that in your head. Okay. But I want to teach you how to do it algebraically. Okay. And so the rule is, we're going to go back over to this rule here, a little note here we're making here. Whatever we do to one side, we have to do to the other side. That's part of the rule. Okay. So I'm going to give you a couple seconds to copy that down. Whatever we do to one side, we must, I'm going to underline must, we must do to the other side. Don't forget that. So I want to talk about example 1 here. 5 plus X is 9. Okay. I want to get X by itself. So there's this, we could call this the addition principle. Okay. All right. Spelled L-E. Okay. Principle. Okay. It's like whatever we add to one side, if we're trying to get X by itself, we can, when we see that we're adding or subtracting, you see how this equation, this side of the equation here, it's got 5 plus X. Because it's adding or subtraction, we're going to add the same thing to both sides, okay, to get rid of this, or subtract the same thing from both sides. So, so what I'm going to do, here's what I would do with this equation. I would subtract 5 from this side, because you see what would happen if I subtract 5 from this side of the equation. And what I mean by this side, okay, I'm going to write this word here. You might want to write this down so in case I was confusing here. So we'll call this side 1. Okay. You see the equal sign? This is side 2. Okay. So just in case that was losing you or confusing you. Okay. We're talking about what's on either side of the equal sign. Okay. All right. So I can look at this equation, 5 plus X equals 9, and go, oh, I'm adding here. So I'm going to subtract something. I'm going to subtract this 5 from this side. And that means I'm going to subtract 5 from this side. So please go ahead and write that in your notes exactly like I just did that. Okay. I want you to have that there. And here's what I would do next. I would go, okay, 5 minus 5 is 0. So I'm going to have X by itself. Does that make sense to you guys? Okay. So you have 5X plus 5 plus X. If I subtract 5 from 5, I have nothing. So 0 plus X is just X. I got rid of the 5 basically. Okay. X equals, whatever I did on the left, I have to do on the right side. So 5 from 9 gives me 4. Okay. Now you go, hey, teacher, it took you 30 seconds to figure out what I could do in my head in 5 seconds. Again, I'm showing you how to do it. The simple equations, one-step ones, because they'll get more complex where you can't just do it in your head always. Okay. All right. Let's look at example 2 here. All right. Just to kind of reinforce what we just did here. I've got x plus 14. Listen to how I'm thinking, okay? I'm going, okay, on this side, I've got a plus here, okay? So I got to subtract something, okay? I can use my addition or subtraction principle, which means when you have, in a sense, it's like doing the opposite. We're doing the opposite. Do you see how we have 5 plus something? So you see how I subtracted? So to get x by itself, I did the opposite of the operation that was going on that side. Look at the number 2 here, x plus 14. What's the opposite of plus? Minus. So you do the opposite, if you want to write this down, to do the opposite opposite to get x by itself, okay? If that helps. So you can write that in your notes too. Do the opposite math, okay? So in this case, the math is plus, so I'm gonna do the opposite. What's the opposite of plus? Minus. So I'm gonna go minus 14 from this side, and obviously I'm gonna go minus 14 from this side, okay? And what that's gonna give me is, if I subtract 14 from this side, hopefully by now you're starting to see this goes away. So I have x equals, and 29 minus 14 is a 5 here and a 1 here, 15, okay? I just solved for x, okay? I did a one-step algebraic equation where I subtracted both sides, I subtracted 14, okay? And please, do you see how I wrote out these steps so I could see what I did? Do that so you don't forget what you're doing and get lost. Let's do some more, okay? I want to walk you through a number of these ones, okay? So we'll call this new equation, new page, equation number 1. I have 9 plus x equals 13. You notice how I've got plus? This is the operation going on in this equation. So go ahead and write 9 plus x equals 13 in your notes, okay? I see this plus sign, and the teacher just said in my notes right here, do the opposite to get x by itself. So what is the opposite of the math going on here? Here's plus, means I'm going to subtract. I would subtract 9 from this side, and don't forget to write it over here before you do anything. Write it on both sides. Now I've got 9 minus 9 is 0, so I've got x equals 4, okay? 13 minus 9 is 4, okay? I'm just going to keep do a couple more just for the sake. This one, the next one is the exact same, okay? I would subtract 14 from both sides. Notice I'm writing this here so I don't forget. This, if this helps you visually, okay, I'm going to do this. See, this cancels this out then. This cancels this out, okay? And I now have x equals 3323 minus 4 is 2019. Okay, I did that kind of in my head there. Okay. Now, so you don't get confused, I have 47 plus 33 equals v. I would just add them together. I would just add these two together and get 33, 0, 1, 7, 80. 80 equals v is what you're doing, okay? X plus 19, subtract 19 from both sides. Hopefully you're getting the idea there, okay? Because we got to move on to some concepts. All right. Now, I want you to write this number 1 here on this slide. I want you to write it in your notes because it's kind of an important one. It's a little bit tricky. And I'll be honest with you, it's in the curriculum for this class. It's in the homework, and you probably have it on a quiz. This is actually going to be more, technically, it should have been considered more than a one-step equation, because that's the title of our lecture tonight is one-step equations here. So I have 9 minus x. Okay. we know that the opposite operation, we have 9 here. If I want to get 9 by x by itself, okay, here's how I want you to do this type of equation. Now, this is different. I want you to notice what's different about this. I'm going to go back to the previous page. You see how I had 14 plus x, the x was on the right side, okay, and it was positive. See how you have a plus x here, okay? This is a positive b here. But in this example I'm now showing you, you have a minus x in a sense. It's minus x, right? So it's a little bit trickier because it's a minus here. Here's what I would do. I would subtract 5 from both sides. I'm sorry, 9 from both sides. Okay. So if I subtracted, I have a positive 9 here. And I'm going to subtract 9 from this side as well. Okay. I know what somebody's probably thinking right now. Hey, teacher, didn't you just about 5 minutes ago say do the opposite operation of whatever's here? And here's a minus. So shouldn't I be pluses? But you just put a minus sign here. This is where it kind of gets to do with the language. They would consider this adding -9 to this side and adding -9 to that side. That's kind of how they get around that language. But anyway, I'm just going to show you how to do this. So I want x by itself. So I'm going to subtract 9 from there. So that gives me what's left here. I have -9. I'm going to change colors so it's really clear what I'm doing here. That means these now cancel out. Okay, so I have minus x here. Okay, that's this here equals. All right, now this is why I wouldn't have put this in this class if I was designing the course, but 5 minus 9 is going to give you a -4. And I know what some of you are thinking, hey, teacher, we haven't talked about negatives. You're right. You'll get into that next quarter. But for now, you're just going to have to trust me on that. It's 5 minus 9 gives me -4, okay? Because this -9 is bigger than +5. So now here's what you would do in an algebra class if they were explaining the full. How do you get rid of a negative x? You don't want a negative x. You don't want a negative y or a negative a. You would multiply each side by -1. Because, and I apologize for the fact that you haven't even heard this yet, and it's not even in your course, because if you multiply a negative times a negative, or if this negative times a negative, it becomes a positive. And if I multiply it by -1, 1 times anything just keeps the number the same, right? But if I multiply it by a negative number, this would turn it into a positive x equals, and if I multiply this side by the -1, 4, okay? And this becomes a positive because a negative times a negative is a positive. All right. I know that went by you really fast, but you see how I got x equals 4? You can look at this and go, well, yeah, 9 minus 4 equals 5. Yeah, that must be right. Okay, you can kind of check your answer. But I'm going to repeat just kind of a general principle. If you get a negative x, okay, and if I had, let me give you a different example. If I had negative x equals 7, okay, then I'm just going to change the sign of both of them. If I multiply this by -1, it would become a positive x equals, if I multiplied 7 by a -1, it'd be a -7. So you see how this was a negative? I changed it to a positive. This was a positive. I changed it to a negative. That's how you would do that. And I apologize because that's clearly not just one step, right? That's 2. All right, let's do a couple more just to illustrate it for you, okay? And you'll have this in your notes. And so if you get stuck, you go, oh yeah, this is how the teacher did this. I have 36 minus x equals 11. Notice I have a minus x here. Okay, that's the one I warned you about. So I'm going to get rid of the 36 by subtracting 36 from this side. Whoops, that's a 36, okay? That means I got to subtract 36 from this side, okay? That is going to cancel out the 36s and leaves me with minus x equals, this is going to be a negative number. 36 minus 11 is 26, 25 minus 25. Okay. You'll just have to trust me on that if you subtract 11 from 36, you get 25. And this is negative because this is a bigger number here. Okay. So I don't want to have a negative x. So if I multiply both sides by -1, that would change this x to positive x equals positive 25, okay? And sure enough, if I look at it, 36 minus 25 equals x. All right. So that's a little bit about negative numbers and dealing with that. This one here, number 4, this is easier because I have really a positive x minus 14. So I would just do plus 14, okay, here, and plus 14 here, or 14 here. And then I would solve the equation. I would go x equals 828. What am I doing wrong? Yeah, these cancel out. So that should be an equals. You see a positive and a negative 14, they cancel out. 14 from plus 28 is, let me just do that. 48 plus 14 is 12, 4, 5, 62, 62, okay? So x equals 62 here. That's how we do it. This is that negative g thing. So I would do it like I said, here's the negative v. So I got to do it like I just taught you. Okay. All right, moving on. Now I want you to go ahead and write this in your notes. One step algebra, when we multiply and divide, how do we do those? Okay, so one step multiplication and division. And go ahead and write down in your notes what it says in red. It says to isolate, which means get it by itself, the variable by doing the reversed operation for the given equation. Okay, that's kind of sounds, I know, kind of confusing. Hang in there. It's basically what I've been saying. Hey, if you're adding on one side, then subtract. So you're going to do the reverse, the opposite to get rid of to get x by itself. You're doing the opposite operation. Okay. All right. Let me give you a few more seconds to copy that. And then go ahead and write down example 1 here. Okay. Let's talk about this. So I have 5 times x. So this little thing here is times, okay? I'll write a little note here so you guys have this, okay? This little symbol here like this. Yeah, 5 times x. And the reason why they use this is because if you had 5xx, it'd be like, is that extra large or something? Yeah, it gets kind of confusing. So this little symbol here means times, okay? So I just kind of wrote that. That's what that symbol means, if you see that little thing. So 5 times x equals 77. All right. Now, the operation, I said to do the reverse operation, okay? The operation going on the left side of the equation here is multiplication, okay? What's the opposite of multiplication? Division, okay? So opposites, so if I writing this in my notes here, if I had to know this, okay? Here's my opposites. They go like this. Opposite of addition is subtraction. Opposite of multiplication is division. And that's about all I need to know. Those are the opposites, okay? There they are. So in this case, I have 5 times x equals 77. All right. If I divide, since I'm multiplying here in my, what we call my expression here, if I divide this side by 5, you guys know what 5 divided by 5 equals? It's 1. So what that really leaves me is 1x. It's just 1 times x, which is just x. So I'm going to divide this side by 5, okay? And what that is going to leave me is, what that does by doing that opposite operation there, that cancels out the 5s, because 5 divided by 5 is 1, times x is just x, gives me x, equals, okay? And if I did 77 divided by 5 real fast on my calculator, I get 15.4, which is kind of a confusing one, but 15.4 on my calculator. And that would be my answer. X equals 15.4. Okay. And by the way, that is decimal again. Okay. So I did the opposite operation. To get X by itself, since I was multiplying over here, I divide to get rid of that. Okay. Let's do some more. Let's take a look, a couple more here. All right. I hate to do this to you so quickly, but I want to show you this particular equation here. Here's example 2 here. I've got X divided by 9 equals 12. You see how that's divided by, and you know that the opposite of dividing is multiplying, okay? Here's what I want you to do. Go ahead and write this down. X divided by 9 equals 12, okay? All right. When you see something divided by something else like this, I'm going to go back to the previous slide here. Yeah, this was times. But when you see something divided by another number like this, write it. X divided by 9 is the same as X over 9. That's the same thing, okay? That means the same. So I'm going to draw a little arrow here. That means the same as X divided by 9. So what you would do here is you would take your X and just write it over 9. So you would have X over 9 equals 12. All right. Now, the way to get rid of, you've got division going on here. I told you is to do whatever we do to one side, we must do to the other. And since this side is doing division, X divided by 9, I'm going to multiply to get X by itself. And what I'm going to multiply is I'm going to multiply by 9. Okay, so go ahead and just copy this. I'm going to multiply it by 9 over 1. And we'll talk about why in a second, because I know some of you are going, you lost me here. Why did you multiply this by 9? Okay. Here's a little rule here. If I wrote it out here in red here, just like a red rule here. If you have 2, okay, which is the same as 2 over 1, okay, to get rid of it or to turn it into basically 1, if I multiplied it by the reciprocal, which is 1 over 2, the opposite of it, okay, that would give me 2 over 2, which equals 1. Okay, so the rule is if you want to get a number by itself, if you multiply it by its reciprocal, it makes it 1, turns it into 1. Okay, which then now it's just 1x, which is the same as just x. Okay, so if I multiply this side by 9 over 1, okay, then I'm going to multiply this side times 9. So what I did is I took x over 9, I multiplied it by 9 over 1. And I'm going to multiply the right side times 9. I didn't say 9 over 1 because it's the same as 9, okay, here. The reason why I put this over 1 is because I see how it's like a fraction here, so I made it like a fraction. The reason I left it by itself over here is because it's a whole number just like here. It's not like a fraction. So, all right, it's the same thing. Now, just to illustrate what's going to be happening now is that by multiplying by the reciprocal here, that cancels out the 9s. And what that leaves me is X equals, do you guys remember what 9 times 12 is? What is that, like 108? Now I'm kind of forgetting. 112 times 9 equals, yep, it's 108. Okay, so X equals 108. Okay, let's do some more. Okay, hang in there, guys. I know this is a lot tonight, so I apologize for that. But example 3 here, I've got 11 times X is 99. Now in my head, I know, oh, it's 11 times 9 is 99. But like I said, we're going to do all the steps so you learn how to do it because it'll get more complex where you won't be able to just do it in your head. All right, so this 11 times, this is multiplication, okay? What is the opposite operation of multiplication? Is division. So I'm going to get X by itself by dividing this side by 11 and dividing this side by 11. So go ahead and just copy that down so you have it in your notes, okay? I'm doing the same thing to both sides, all right? And what that's going to do is, I'm going to just kind of illustrate for you, that cancels out the 11s here, okay? And that leaves me with X equals, 11 goes into 99 9 times, okay? So again, I got my X by itself by doing the opposite operation from what is going on this side that has the X on it, Okay. All right. Now, this number 3 here, I'm not even going to do it, but see how it just says 47 times 23 equals V? So I would just multiply those two numbers together, and that would give me the answer. Okay. So I'll go on to number 4 here. X times 14 is 322. Go ahead and copy that. X times 14 is 322. Okay. And again, teacher said to do the opposite operation in this side of the equation. The operation that is currently there is times. What's the opposite? Division. I'm going to divide this side by 14. That's what the little fraction thing means here. Okay, it's like divided by. Okay, divide the other side by 14, and that leaves me with x equals 322 divided by 14, which is 322, right? Yeah. 322 divided by 1/4 equals 23. Okay. Now, all right. So number 5 is the same game. Number 6 is the same game, the same kind of equation. So I'm going to skip those. Okay. Give you a couple seconds. Make sure you copied that and moving on. All right. 36, it's the same thing. This is 36 divided by x equals 6. I'm going to rewrite that as, well, let me just do it underneath here. This is how I rewrite it. 36 over x equals 6. Okay. That's how I would rewrite the equation, because it says divided by. Now, I'm looking at trying to get, you see how I have division here, 36 divided by x. I want to get x by itself. So if I multiply each side by, if I multiply each side times x, well, that becomes kind of a more complex problem. But if I multiply both sides by x, then I would have 36 equals 6x. And then I have to do another step, which I kind of wrote out here in blue beforehand, just as a reminder what you would do here. But hey, I've got a question. Let me just jot here. Yes, you can. Yeah, have a great choir practice. Sounds fun.
Thank you. Bye-bye.
I miss singing in choirs. So what I would do on this one is I'd multiply each, you could multiply each side by 1 over 36. Okay. I don't know if that seems kind of confusing to you, but I could, if I multiply this by 1 times 136, 1 over 36. I'll show you why. Remember I said if you multiply by the reciprocal, okay, and that means I'm going to have 6 over 1 times 1 over 36. All right. What that's going to do, if I illustrate this with my colors here, that is going to cancel out the 36s, and I'm going to get x equals 6 over 36, which reduces down to 1/6. Okay, that's real tiny there, but that's what that would do to solve this. All right. All right, number 2, real fast, kind of looking through that one. I have 45 divided by x. Okay, like I told you, turn this divided by thing into a fraction. Write it out as 45 over x equals 9. Okay, go ahead and copy that. And what I do from there is what I would do, this is supposed to be an x here. Okay, if I multiply this side by 1 over 45, which is the opposite of 45 over 1. Okay, that's the whoops, this is a 45. Okay, so that means I got to do the same thing to this side times 1 over 45. Why did I do that? Because you see this 45 here, the reciprocal of it is 1 over 45. That's going to cancel out these 45s. That gives me x equals 9 over 45. Okay, remember from our multiplication of fractions, 1 times 9 is 9, 1 times 45. This reduces down to 9 goes into itself once and into 45 5 times. So 1/5 is my answer. Okay. All right, that's a number of examples where you have division here. Okay, where you turned it into a fraction and then multiply by the reciprocal, trying to get x by itself. Okay. All right, moving on. X over 7, again, I'm just go ahead and write the equation. I won't do the whole thing. I'm just going to show you how I would set it up. I would go X over 7 equals 49. And then what I would do is I would go, okay, I want to get X by itself. So what I'm going to do is I'm going to multiply this side times 7, which is the opposite operation of division. This is a division thing here. The opposite is to multiply. And I'll multiply this side times 7. And that will give me, like, that'll lead me to figuring out my answer. Okay. That means X equals 328, 63, right? So 28, 9, 60, no, 40, 54, 543. I think that's about right. Doing 49 times 7 here. Okay. Okay. I think I've done enough. I think you have all the basic concepts here. Let me see. Oh, look at this one here. 5. Oh, 19 plus X. Oh, that's the easy kind. This is plus, right? I'm just going to subtract 19 from this side. I'm going to subtract 19 from this side. That leaves me X equals 27, 17. What am I doing? 7 minus, what does that equal? I'm trying to do that in my head. 27 minus as a 5, I think it is. Okay, real fast. Hopefully I did that correctly. This one here, you see how it's the minus X here? You see this minus X here, guys? Okay, 108 minus X. Remember I told you? Okay, that's that minus X thing here. I could subtract 108 from both sides to get X by itself, minus 108. Okay, well, that leaves me is a minus X equals, let's see, 60, 48. This is a minus 48. Okay, and the reason why I got that real fast is I subtract 59 from 108. I think that's about right. How did I do that? So, oh, I'm subtracting, yeah, 108 from both sides, minus 59. Boy, I better do that 108 over here. I can do it real fast because I did it real fast in my brain and I can't remember how I did it. So if that's 0, I did it wrong, didn't I? 108 minus 58, right? Am I doing the right? 108, I'm sorry, this is a 59 here. This becomes 0, which becomes a 10, which becomes a 9, which cancels out. 18 minus 9 is 9, 49. Oh, that's close. 18 minus 9 is 9. This would be a 9. Okay. I think we've done about enough. Let's see what else I have here. Division problem here, 144 divided by 12 here equals X, just so you know. You'll notice if I just do the math here, 12 goes into 144 12 times. 12 equals X, okay? It's the same as if I rewrote it as 144 over 12, and 12 goes into it 12 times. 12 times 12 is 144, I think, okay? X plus the next equation here, I've got X plus 248. Oh, this is a nice easy one. It's just plus here. There's no minus X here. I'm just going to subtract 248 from both sides. Do the same thing to both sides, 48. And that will give me X, okay? All right. Here's X minus 473. If I just add, what's the opposite of minus? Adding. So if I add 473 to this side, I have to add 473 to this side. And that will give me X equals 7, 7, 9, 10, 11, 12, 13, 1,377. Okay. Okay. Hopefully you're starting to kind of get this. This one here, number 11 here, X times 7. You notice this is times. What's the opposite operation is the division. So if I divide this side by 7 and divide this side by 7, that gives me X equals, and that gives me the answer, okay? Here's X over 24, or I'm sorry, X divided by 24 equals 552. Remember, I told you when you get a division symbol like this, rewrite it as x over 24 because it helps to figure out what to do, basically, equals 552. All right, so what I would do, now you look at that for a second, x out of 24. How would I get x by itself? Remember I said that you got to do the opposite operation? This operation is division, which now is rewritten like this. I got to multiply something to get x by itself. What would I multiply this by to get x by itself? If I took 1 over 24, which is the reciprocal. Did I do that wrong? No, yes, I did. 24, I'm sorry. Let me erase that real fast, guys. Okay, if I took, this is 24 on the bottom, so I'm going to multiply it by its reciprocal, which is 24 over 1, okay? Why did I do that? Because now these cancel out. I have 1 over x, which is just x, okay, equals, I have to do the same thing to this side. What did I multiply it by? 24 over 1. And that's going to give me a big number in the thousands, okay? Which makes sense if you look at the actual equation. I'll give you a few more seconds to copy what I just wrote down there. All right, now let me just review, okay? And first of all, I want to review what all we're doing. This week, we're cramming 2 weeks into one, which I warned you all along we're doing because it's an 8-week quarter. We're doing it, a 10-week quarter, we're doing it in 8 weeks. So the whole second slideshow here on one-step equations is packed into this week. And the reason I put it in this week in particular was because, in my opinion, okay, the subtracting and adding of decimals, which we were talking about right here, is pretty easy because all you have to do is line up your decimals and then add or subtract, depending on what you're asked to do here. All you do is line up the decimals, okay? So that you can hopefully get that pretty quickly, kind of grasp that concept, okay? So that is specifically why I've chose to put adding these one-step equations, which we've been working on for the last half hour here, into this week, because it just kind of made sense. It would be easier on you. So the rule is when you're adding or subtracting decimals, line up the decimals all the way in, including in the answer, then start doing the math and you'll get it right, okay? The rule when it comes to working with one-step equations, okay? We kind of talked about this, but I'm just kind of quickly going to review here, just a couple of reminders, all right? That when we are doing these one-step equations, okay, whatever you do to one side, you have to do to the other. And when we're talking about side, we're talking about the side of the equal sign, okay? And the rule is, this next rule along with that is, if I had 5 plus x is 9, whatever type of math is going on this side of the equation, if I do the opposite type of math, that will lead me to getting x by itself. So since we're adding here, if I subtracted 5 from both sides, I got x equals 4, okay? Since I'm adding here, I'm subtracting here. Going to the next slide, I had pluses, so I'm subtracting pluses, I'm subtracting, okay? These are all the same as what I just said. Then we talked to you about, what about when I'm subtracting, but we have a negative x, okay, here. Well, I said to go ahead and just do the same thing. This is a positive 9. Subtract 9 from both sides and get negative x equals negative 4. And when you have the negative x, just flip the signs on both sides, basically, because that's what would happen if you multiplied by negative 1. So this is a negative sign, so I flipped it to a positive sign. This is a negative sign, so I flipped it to a positive. Math algebra students just get used to doing that. Whenever they see an answer like that, they just flip both sides, because it's the same as multiplying each side by the same thing, negative 1, which would flip it, okay? Again, this next one's the same. So we're going on here. We talked about, yeah, all these are easier ones. Just add 14 to both sides. We talked about multiplication, okay? When you see that you're multiplying, what's the opposite operation of multiplication? Is division. So we divided both sides by 5 and got x by itself, okay? opposite operation of what's going on the side of x is what you're going to do to get x by itself. Okay. And I have a little reminder here in bright green. Make sure you remember whatever you do to one side, you have to do it the same operation to the other side. Otherwise, you kind of messed up. Okay. And then the last thing I want to remind you of is if you get something like this, x divided by 9, okay, you see the division here, write it out as a fraction. And then it'll make it visually easier to kind of figure out, oh, I'm going to multiply by the kind of the reciprocal to get x by itself. Okay. All right. How did we do for time here? I did all of that and not too bad. It's only 5 after 7. I'm going to take questions. First, I'm going to stop my recording. If you're just watching this now, have a spectacular evening and stop recording.